Dear friends, welcome to my video on quantum theory versus quantum mechanics. Kindly click on the CC button for subtitles. Quantum theory and quantum mechanics are terms often used interchangeably, but they hold subtly different connotations in the realm of physics. To understand their distinctions and similarities, it's essential to delve into their historical context and the concepts they encompass. Quantum theory is a broad term that refers to the theoretical framework of modern physics that explains the nature and behavior of matter and energy at the quantum level. It encompasses a range of theories, including quantum mechanics, quantum field theory, and quantum electrodynamics, among others. The term quantum theory is often used when discussing the philosophical, foundational, and interpretative aspects of quantum physics. Quantum mechanics, on the other hand, is more specific. It is the branch of quantum theory that deals with the mathematical description of the motion and interaction of subatomic particles. Developed in the early 20th century, it includes the fundamental principles and equations responsible for describing the behavior of particles at the atomic and subatomic levels. The birth of quantum mechanics is usually attributed to the pioneering work of Max Planck in 1900. Planck proposed that energy is quantized, meaning it can be released or absorbed in discrete chunks, quanta, rather than continuously. This idea was revolutionary as it contradicted the classical physics view that energy changes are continuous. Building on Planck's work, Albert Einstein, in 1905, proposed the quantum theory of light. He suggested that light could be thought of as discrete packets of energy, which he called photons. This theory helped explain the photoelectric effect, where light knocks electrons off a material's surface. The development of quantum mechanics accelerated in the 1920s with significant contributions from physicists like Niels Bohr, Werner Heisenberg, Erwin Schrödinger, Max Born, and Paul Dirac. Bohr introduced the Bohr model of the atom, which incorporated quantum theory to explain how electrons orbited the nucleus. Heisenberg developed the matrix mechanics formulation of quantum mechanics, and Schrödinger came up with wave mechanics. These two formulations, seemingly different, were later proven to be mathematically equivalent. One of the most remarkable aspects of quantum mechanics is the principle of wave-particle duality. This principle posits that every particle exhibits both wave and particle properties. An electron, for example, can be described both as a particle and as a wave. This duality is central to understanding phenomena like the famous double-slit experiment, which demonstrates that light and matter can display characteristics of both classically defined waves and particles. Another cornerstone of quantum mechanics is the Heisenberg Uncertainty Principle. This principle states that certain pairs of physical properties, like position and momentum, cannot be simultaneously known to arbitrary precision. In other words, the more precisely you know the position of a particle, the less precisely you can know its momentum, and vice versa. Quantum mechanics also introduces the concept of quantum entanglement, a phenomenon where particles become connected and the state of one instantly influences the state of the other, regardless of the distance separating them. This phenomenon was famously referred to by Einstein as spooky action at a distance. Despite its success in explaining many aspects of the microscopic world, quantum mechanics has also led to philosophical and interpretative debates. The Copenhagen interpretation, one of the oldest and most widely taught, posits that a quantum system remains in a superposition of states until it is observed, at which point it collapses to a definite state. Other interpretations, like the many worlds interpretation, propose that all possible alternative histories and futures are real, each representing an actual world or universe. In summary, while quantum theory is a broad term that encompasses the entire spectrum of theories dealing with quantum phenomena, quantum mechanics refers specifically to the mathematical framework that describes the behavior of particles at the quantum level. Both have profoundly changed our understanding of the universe, challenging and expanding upon classical notions of reality, causality, and determinism. Thank you for watching my video. Kindly subscribe to my YouTube channel and give a thumbs up. Thanks for your support.